Evening, everyone, and welcome to our presentation on compliant mechanisms. My name is Prince Ponta, and today I will start this presentation. As an extended part of our TMM1 course, we are here to explore the fascinating world of compliant mechanisms. Compliant mechanisms are an innovative class of mechanisms that rely on the deformation of their constituent parts instead of traditional rigid body links and joints. Compliant mechanisms can be found in many applications, from simple everyday objects to high tech devices in various fields, including aerospace, robotics, medical devices, and more. In this presentation, we will dive into the history of compliant mechanisms, their usage, advantages, and types, as well as the design process and the scope of this exciting field. So, without further ado, let's begin our journey into the world of compliant mechanisms and discover the possibilities they hold. But before we do, let's take a moment to acknowledge our course instructor, Assistant Professor Sanjay Neupane sir, for providing this platform to explore beyond our syllabus. To begin, what is compliance? It is the property of a material that is undergoing elastic deformation. Mathematically, it is equal to the reciprocal of stiffness. So we get compliance C is equal to X upon F. That is the reciprocal of stiffness that we learned in spring theory. Now, if we use this property, you will get a compliant mechanism. For example, the tip of the stylus or pen is fixed in this given video, even though you move the flexible body. It is like a chicken head. Thus, a compliant mechanism is a flexible mechanism that achieves force and motion transmission through elastic body deformation. And if something bends to do what it is meant to do, then it is compliant. And if that flexibility allows it to bend also helps it to accomplish something useful, then it is a compliant mechanism. Now, in this example, a particular motion is achieved using compliant mechanism. As seen in the video, the joints are compliant, that is flexible. Now, where can we find such mechanisms in action? Before we answer this question, let's watch a short clip. On this clip from the tailor of our planet, we can see nature and evolution using compliant mechanisms everywhere and for everything. But when did human first use compliant mechanisms? To trace back in the history of human evolution, it is found that the compliant mechanism was first used in the bow and arrow. The flexible bow string was used to store potential energy and throw arrows at an immense force to kill and strike prey and as well as protect from predators. Also, human history has been divided into Bronze Age and Iron Age. But what made those ages possible? The bellows that blows air into the furnaces to get higher temperature for melting the metals. These bellows use flexible, compliant mechanisms. Also, many diagrams from the Da Vinci's book of engineering finds application and examples designs of various compliant mechanisms. As an example, a compliant catapult is shown in this video, which was inspired from the Da Vinci's drawing. Now, what is the present context? Do we still use such mechanisms and where do we use it? It is used in everyday objects like nail cutters, clippers, safety pins, hair clips, tiara, toilet mop, remote buttons, door handles, badges, telephone wires, clips, keychains, joysticks, milk bottles, tongs, headphones, keyboard buttons, joystick, mouse, dispensers, weighing machines, pens, staplers, comfortable chairs, comfortable mattresses, suspension systems, and many more. we use it everywhere. In this particular, the research has been going on for for compliant wings instead of the fixed wings of the airplanes, in which the wings can be bent using the compliant mechanism reef to gain more efficiency and more lift. And even in bionic, compliant has is playing a great role. Even in entertainment, compliant has been used in many sports, and even in musical instruments. In healthcare, compliant mechanism is being used everywhere. And moreover, nowadays in robotics, compliant is replacing the traditional rigid body joints, and especially in biomimicry, in which the bird wings motion is mimicked using compliant mechanism. The eyeball motion is being mimicked using compliant mechanism, and the exoskeleton hand mechanism is mimicked using compliant mechanisms, as shown in these videos. Now, I would like to call Nirmal up on the stage, up on the slide.